Hello, welcome to Noise Control and its Management. Today is the second day of the 7th week of this course, and we have been discussing about what makes a microphone good from the standpoint of producing good data and which help us analyze the problem more accurately. And what we have discussed till so far are that there are 4 important parameters, actually 5 parameters, which are important in terms of figuring out whether we have a good microphone which meets our needs or not. The first one we had discussed was linearity. The second parameter we discussed was that the response spectrum or of the microphone should be a flat one. The third parameter we had discussed was that microphone should be very sensitive, and we had also discussed about transient response. And then the last important parameter which we have mentioned but not discussed in somewhat detail is about directivity. So, we will quickly recap some of these parameters and then we will talk about directivity in more detail. So, this is the couple of slides on microphone sensitivity and how are microphones specified in technical literature. So, sensitivity is an important factor while doing any measurement related to noise. Commercial microphone provide a calibration chart. So, we will actually see one of these charts and we will try to understand how it is represented, and this chart helps a lot for noise measurement purposes. So, it is very useful, and whenever we are selecting a microphone we should look at this chart carefully and see whether it meets our needs. So, this is the chart for a particular microphone. This microphone is manufactured by a company called B&K. So, this is the name of the manufacturer, and it says multi-field half or quarter inch microphone. So, the diameter of the microphone is 1/4 inch, and remember we had discussed that microphones comes in 3 types: pressure field microphone, random incidence field microphone and free field microphones. So, this microphone they say is multi-field. So, what does that mean? It means that it will work in all 3 of these fields. So, that is what it means, multi-field microphone, and its diameter is 1/4 inch. And why is this important? We will see later, and this is some number. Then of course, there is a serial number for a microphone, and it says, see this, that its sensitivity is equal to minus 23.5 decibels, and we had mentioned that LS equals whatever, but we also have to specify the value of Y ref, right. So, the value of Y ref is mentioned here, reference equals 1 volt per Pascal, okay, reference equals 1 volt per Pascal. So, LS equals minus 23.5 decibels if we use a reference microphone such that it produces 1 volt for each Pascal. And if you use the relation which I had explained earlier, which was LS equals 20 log Y by Y ref, and this is minus 23.5 decibels, then Y equals Y ref, which is 1 times 10 to the power of minus 23.5 divided by 20. So, if you do the math, it comes to 66 millivolts per Pascals. So, it says that LS equals 20 log this minus 23.5 decibels is same as saying that the microphone will generate 66.6 millivolts when it is excited by 1 Pascal of pressure. Okay. And then of course, whenever there is an instrument, it has some margin of error. So, the maker is saying that there is an uncertainty of 0.3 decibels, which means the sensitivity could be somewhere between 23.8 and 23.2, minus 23.8 and minus 23.2, somewhere in that range. Okay. and then they said that they have made all these measurements at 23 degrees centigrade. At that time the pressure, static pressure was 101.3 kilopascals, humidity was 50%, and they made this calibration at by checking the microphone at 251.2 hertz. So, they actually measured the sensitivity at 251.2 hertz. They generated a sound at 251.2 hertz, and then they measured how many pascals it is producing, and they found that it produces 66 millivolts per pascal. Okay. So, these are the things, and then of course, there are some other standards they have used and all this is there, but then they have also given us a chart, and it is important to look at this chart and see what it means. So, on the x axis what they have done is they have plotted the frequency, they have plotted the frequency, and on the y axis they have put something decibels. So, what does that mean? That if this decibel is 0, okay, for instance at 100 hertz it is 0, at 200 hertz it is 0, at 1000 hertz it is again 0, at 50 hertz it is again 0. So, in this range what is the sensitivity? The sensitivity is minus 23.5 decibels, it is flat. From 50 hertz to 1000 hertz, the microphone sensitivity does not change, it remains flat and stays at how much? 23.5, minus 23.5 decibels. Okay. Maybe you can also say maybe it goes up to 2000 hertz. Below 50 hertz, what happens to the sensitivity? The sensitivity starts to drop. So, suppose I want to figure out what is the sensitivity of the microphone at 10 hertz. So, I look at this graph, and at 10 hertz this thing comes to minus 1. So, at 10 hertz the sensitivity of this microphone will be what? Minus 23.5 minus 1, which is minus 24.5. Okay. Same thing here at let us say 1.5 hertz, the change in sensitivity is minus 15. So, the sensitivity of the mic drops down further, it becomes more insensitive, and it becomes minus 23.5 minus 15, which is minus 38.5 decibels. Okay. So, this is the response of the microphone, and so we had said that the response should be linear, which means the response should remain constant, it should be linear, and it should also be flat. And what we see is that the microphone has a flat frequency spectrum in this range from 50 hertz to 2000 hertz. Beyond 2000 hertz it is no longer flat. So, then we have to see what is the, how does it change. Last thing, they had said that it is a multi-field microphone. So, the response of the microphone in all the 3 fields, it does not change, but at higher frequencies it starts changing. So, now they have 3 lines, okay. This is one line, this is second line, and this is third line, and they say that the lower line, which is this one, this is lower. So, this is for minimum response, this line is for the free field response, this line is for diffuse field response, because it says middle is diffuse field response. Okay. So, below 2000 hertz we have a common line which gives the response for all the 3 fields, diffuse field, free field, and pressure field, but for above 2000 hertz we have to see which particular line do we use. If we are in free field conditions, then we use the upper line, if we are in diffuse field, then we use the middle line, and so on and so forth. So, that is how we use this chart. So, it is important to understand how to use this chart, because it gives us a lot of information. This is a lot of information. Now, we had said that there are 5 parameters: linearity, frequency response should be flat, sensitivity, transient response, and the last thing was directivity. So, what does the directivity mean? So, we have discussed earlier that microphones could be directional in response, and what that means is that if you don't choose the microphone of the right size, your microphone may be sensitive to some particular direction and it may not be sensitive to other direction. When does that happen? So, this is an important slide. It says that diameter of the microphone plays an important role while selection of measurement for microphone for measurement purposes. Okay. So, microphones come in different sizes. You can have 1-inch microphone, they are really fat mics, or you can have ½ inch in diameter or 1/4 inch diameter, and there are some special microphones, they are even thinner, they are something like 1/8 inch in diameter. So which size do we pick? If we are interested that the microphone should be sensitive to sound from all the directions, then we look at this table. If we are looking for, if we have a 1-inch microphone, then it will be pretty omnidirectional for this frequency range, 20 to 3000 hertz. But if I increase the frequency 3000 to 6000 hertz, it will start becoming slightly directional. Okay. So, in some directions it will be more sensitive, in other directions it will not be equally sensitive. If my frequency goes up further, then its performance becomes really bad, and beyond 10,000 hertz we should never use a 1-inch microphone. I will say even beyond 6000 hertz. So, what do? I go for a thinner microphone. The thinner microphone, ½ inch, works pretty well up to 6000. 6 to 10K it is kind of okay, and beyond 10,000 it is not good at all. So, again, if I have to go up to 10,000, then I use a 1/4 inch microphone, and then I think I will be okay for the entire spectrum. So, again, depending on what frequency spectrum we think our signal will have, we also have to choose the right size of the microphone, because that influences the directional characteristics of the microphone very significantly. So, that concludes our discussion on microphones. Starting tomorrow, we will start discussing that suppose we have a problem at hand, and what we are interested in, suppose we are outside the room or outside in a free field environment, and there is some machine which is creating noise, and we want to figure out how to solve that problem. Then what should we do and how do we go around doing that? Or for that sake, another problem could be that suppose you are developing a factory. Okay. So, in a factory, what do you have? You have a large room, and in that room there could be 30-40 different machines, and each machine makes some noise, and you want to make sure, right now there is no factory, but you are just starting to build the factory, and you want to make sure that the noise levels remain manageable, they do not become excessive. So, you have to do some basic calculations to figure out what kind of noise levels will be there in that room when you will have installed all these machines. So, how do you make those type of calculations? So, what we will learn in the remaining part of the week and also the next week is how do we, before actually something has been made, how do we estimate what kind of noise levels will be there, whether we are inside a room or whether we are on the outside, because that is very important, because once you have an idea, oh, that okay, the noise level, if I use these machines and this is the size of the room, then it will be at this location, 120 decibels. If I have that understanding, then I can figure out whether I want to reduce it or I live with it or I can tolerate even higher noise. So, this is what we plan to do in the next 4 lectures and also in the next week. So, with that we conclude our discussion for today, and I look forward to seeing you tomorrow. Thank you very much. Bye.